We are solving two problems in current electricity. First NEET 2016 problem basing on Kirchhoff's voltage law. The potential difference between VA and VB is asked to find out. So it's a part of a closed circuit. So when you are having a Kirchhoff's voltage law, you know the sign convention. This is how the current is passing in that. So as current, assuming like as it is given that the current is passing from A to B, we can assume that as current flows from higher potential to lower potential, VA is greater than VB. So I will consider VA as positive and VB as negative for the flow of the current. So starting from here, we shall also consider a direction. Let us consider this direction that we have taken. We know according to Kirchhoff's voltage law that if the direction of the current is similar to the direction that we have chosen, treat that potential drop as negative. If you get the positive plate of the battery first, treat that EMF as negative. These are the basic rules that we have. So what we can say, according to Kirchhoff's voltage law, VA, this is the direction that we have imagined. This is the direction in which current is passing given for us. So both are same. So potential drop across this is negative. So minus IR. But that I is given for you as 2 amperes. 2 into resistance is also given like 4. While we are going, we are facing first positive plate of the battery, then the negative plate of the battery. That EMF is negative as per the sign convention. Here also we are going in the same direction in which the current is passing. So that potential drop is also negative. Minus IR, I is 2, R is 1 here. Minus VB equal to 0 in a closed circuit. So I can write VA minus 4 minus 3 minus 2 minus VB equal to 0. So VA minus VB is, this is minus 9, on the other side it becomes plus 9. So your answer is 9 volts. So it's a simple Kirchhoff's voltage law application. That's the first problem. Now we are going to solve a different AIPMT problem. What it says is, two cells having a same EMF are connected in series through an external resistance R. Cells are having internal resistances R1 greater than R2. So they are different internal resistances. When the circuit is closed, potential difference across the first cell is 0. What's the value of the R? Let us try to draw what he is saying, right? He is saying there are two cells. So this is cell 1 having EMF, having EMF E, same EMF. Each cell has some internal resistance. Let me call that internal resistance as R1. Internal resistance always behaves like a series resistance. This is second cell, same EMF means EMF is E, but has a different internal resistance. This is the source of the circuit. All this is connected to an external resistance as it is shown. This is what your circuit is, right? So what is the current in this circuit is, I can write now current in the circuit when it is connected is I equal to total EMF. E and E are in series, so total EMF is E, 2E. Total resistance, you know, internal resistance behaves like a series resistances for the external resistance. So total resistance is R plus capital R plus R1 plus R2. That's given for us. It is further given, when the circuit is closed, potential drop across the first cell is 0. What is that potential drop across this first cell? V. So across this potential drop equal to 0. So we can write potential drop across first cell V is E minus IR1. Why minus IR1? Because current in the internal potential drop in the internal resistance always oppose the flow of the current. That's why, because of internal resistance, total voltage across the resistor V is always less than that of EMF. We know that fact. He said that is equal to 0. From here I can write E equal to IR1. That implies I equal to E by R1. So the total current is supposed to be this much, but when V across the first cell is 0, current is this much. But as they are all in series, current is going to be the same. So this I can be equated to this I. As I's are same, I can equate these things as what? 2E by capital R plus R1 plus R2 equal to E by R1. E and E will cancel. Cross multiply. 2R1 equal to capital R plus R1 plus R2. So get that R1 this side. 2R1 minus R1, get also this side, minus R2 equal to R. 2R1 minus R1 is R1. So R1 minus R2 equal to capital R. So the value of capital R is R1 minus R2. That's how we solve this problem. It's a simple problem. Just you need to apply basic concepts itself to solve the problem. Thank you for watching.